Welcome you all today lecture series. Before we enter into the topic, let me introduce myself. I am Vijay Lakshmi, working as assistant professor in the Department of Computer Science and Engineering, Kamaraj College of Engineering and Technology. So today topic I am going to discuss with you is basis path testing. So this is the one of the technique which is under the testing process. So what is basis path testing? So before we see the basis path testing, first we all know about what is testing. So testing is the process which is executing the program to find the intention of some of the errors present in the program or not. Okay. So this testing can be have the more different techniques. So as we follow this, one of the technique is basis path testing. So what is a basis path testing? So basis path testing is nothing but to derive the sum of the test cases present in the program or not. This testing can have the more number of steps. This testing can have the more number of steps. First steps to find the main steps is to find the cyclomatic complexity, with this to create the control flow graph and to find the independent path belongs to this basis path testing. Okay. So let me discuss with this with one simple example. Okay. I will take this example and explain what is the basis path testing and what are the steps followed to derive the test cases. Okay. Let me take this simple example. This is the example to print the value of x and to compare the two values, then it will print the x value. Before we know that how to derive the test cases, first we simply know what is the basis path testing can have the steps one by one. The first step of the basis path testing is to calculate the cyclomatic complexity. Okay. The main thing is to calculate the cyclomatic complexity. In the cyclomatic complexity, we have to draw the sum of the flow graph and to find the independent one, finally we get the result. So this is the method which is to be used by this basis path testing. So before we see the example, we know about what is cyclomatic complexity. Cyclomatic complexity is nothing but some of the calculation unit of the basis path testing. So in that calculation unit only we are going to derive the test cases belongs to the given code. So the code we have to be taken here is the example is, see this is if to print the value of x. So for the simple program you should have the 7 steps of coding. So with this 7 steps I am going to take the test cases. For this I am going to find out the cyclomatic complexity, then also independent path belongs to this code. Okay. Let us see, let me move to see this one by one. So this is the step 1. After writing the or designing the code, the step 1 to draw the flow graph for the given code. So how we should draw the flow graph? So first we take the, first we see the coding. In that coding you write the steps first. So this is the step 1 of the statement of line. This is statement 2, statement 3, statement 4, 5, 6 and finally 7 statements. So these are the 7 statements of line for a simple scenario. So now I am going to give the detail about how we can draw the flow graph for this coding. So this is the control flow graph of the given code. So I already told you that I write the statement of the line 1 is to 7 statements for the given coding. So for this I have to draw this control flow graph. So it will be start from the starting node 1 and the adjacent node of 2, 3, 4, 5, 6, 7, totally 7 steps. So I have to draw like this using the nodes formation for the given code. So here you notify that what are the nodes belongs to here is 2 is the node is divided into 2 parts 3 and 4 and finally 5 it will be connected to the 5, 6 and 7. So this is based on full and this is based on full of the coding right for the given scenario. So see here the coding is if x equal to 0. So the first step you draw the node here is, node 1 is the first step, x equal to 300. To start with the starting node x equal to 300, and the you see the coding of the second step is, then if y is greater than z, then x is equal to y. So, these two steps are how can we use for this control flow graph. So, let me see. So, after the x equal to 0, the compiler going to move to the next step. So, it will be execute the second step. So, in that coding then x is greater than y. So, in that coding if you see, if y is greater than z, so you write the y is greater than z here. If suppose y is greater than z, then it will be moved to the third node, or otherwise it will move to the fourth node. Okay. So, in the third step what they are given in the coding, then x is equal to y, else x is equal to z. Okay. So, how it will be followed for the graph. So, here x equal to y, x equal to z you write. So, up to this 4 steps of the line of statement will be covered by this control flow graph. See here, what is the fifth step? End if. So, how you will going to end the flow graph. So, this is the end if, this is the another end if, this is the x value. Okay. So, if either our choices x is equal to y or x is equal to s, it finally comes to the end of the statement. Then this is the overall statement has to be end by the starting node 1 is to 6, then finally you get the result of x value. So, this is the control flow graph of the given code. So, after this flow graph has been drawn, we have to be moved to the second step is, in the second step we have to be identify the independent path. So, how we are going to determine this independent path here is, so it is very easy. So, the independent path is nothing but how we are going to get the result from the starting node to the destination node. So, here the starting node is 1, then after 2, 3, 5, 6, 7. This is one of the way to get the result, or another one side is 1, 2, 4, 5, 6, 7. This is one of the way to get the result, or the third one is direct of 1 to connect the sixth node, then after you finally get the result of 7. So, this 3 independent path has to be determined by this given flow graph. So, I will show this by the diagrammatical representation. So, here the 3 path of the independent path has to be drawn here. So, I will already told you that the starting node 1, 2, 3, 5, 6, 7, this is one way to get the result, and this is another way, and this is the third way to get the result. So, now we cover the 2 steps. One, we draw the flow graph, a second step we determine the independent path. Then what is the final solution? How did you get the final solutions? Is by the to calculate the cyclomatic complexity. So, in this cyclomatic complexity we use some of the formulas. 3 formulas here to be used, that is V of g equal to E minus n plus 2. So, this is one of the formula, and V of g equal to P plus 1, this is another formula, and V of g equal to R plus 1 is the third formula. So, for this 3 way we are going to find the cyclomatic complexity. For all the 3 way you get the result as the same. Okay. How did you get the, how did you calculate the cyclomatic complexity? Is very easy. So, again we move to see the flow graph. Here if you see the flow graph, so number of nodes, first we calculate the number of nodes. So, here the number of nodes is to be 7, because we are giving us a number 1, 2, 3, 4, 5, 6. So, number of nodes is 7. What is how we calculate the edges? So, we calculate the edges of the connection between the one node to another node. So, here the first node it will be connected to the second node is connected to third and 4, third and 4 will be connected to 5, 5 is connected to 6, 6 is connected to 7 and also 1 is connected to 6. So, totally here having the 8 edges, you consider this edges also, okay. So, E equal to 8, okay. So, now let me see the cyclomatic complexity formula. Okay, here if you see the cyclomatic complexity formula is E minus n plus 2. So, the number of edges is 8, we have to be calculated, and number of nodes is 7, we have to be calculated. So, 8 minus 7 plus 2, we get the result is 3. So, here we calculate the values by using the edges and nodes. Now, the second formula, here we calculate the number of cyclomatic complexity by using the conditions. So, again we move to the flow graph. Okay. So, what are the conditions? So, here the two conditions is to be used. One is starting if x is equal to, if you see the coding, two conditions are used. If x is equal to 300, then if y is greater than. So, two conditions are used here. So, we take the p value here is 2. P value is nothing but predicate node. Predicate is nothing but the condition node. So, the predicate node here is a 2, 2 plus 1 equal to 3. So, we get the second way of result is also using the cyclomatic complexity is also 3. Okay. So, then third, using regions to find the cyclomatic complexity. How it will be calculated? Again we move to the flow graph. So, here if you take the region, so regions mean nothing but the four side of the nodes, it should be covered, it should be covered within that covering unit we will take as a region. So, here if you notify that the node 2, 3, 4, 5, the 4 nodes are to be the covered place. So, this will be take it as the one region, and the outermost region is 1 is to 6 is to be the covered area. So, this is to be of second region. So, there are two regions used in this flow graph. So, the region is 2. So, 2 plus 1 equal to 3. So, for all the 3 calculations, we get the result as the same of the value is 3. So, moreover for this given code, 3 test cases can be used to derive the program whether it should be the condition is true or false. Thank you.